Hello everyone, this is Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about a case study on nuclear disasters and their environmental consequences. Before going into the topic, what do you mean by nuclear energy? We know that nuclear energy is the energy that exists within the nucleus of an atom. Here we have two types, one is nuclear fission, another one is nuclear fusion. In fission, the splitting of larger nucleus releasing huge amount of energy. In nuclear fusion, the combining of smaller nuclei to form heavier nuclei releasing huge amount of energy. See here how this nuclear fission energy produced. Here we have neutron and uranium-235 at level 1. An intact uranium-235 nucleus is about to be struck by a neutron, and in level 2, when struck by a neutron, the uranium-235 nucleus splits, forming new elements and releasing several neutrons plus energy. In level 3, the released neutrons strike other uranium-235 nuclei, and level 4, this nuclei split and release neutrons and huge amount of energy. Okay, if a nuclear reaction is not controlled, what would be happen? Actually, this nuclear energy must be harnessed. It is used to make energy because the nuclear reactions in a nuclear power plant to occur in a controlled and manageable manner because it releases energy very slowly. Here, in power plants, the heat is generated and used to boil water, creating steam. This steam turns turbines which rotate electric generators and creating electricity. The steam is released from cooling towers. See here, this picture, it clearly shows the scenario in power plants. Okay, see here, how does a nuclear power plant work? Here we have condenser, reactor vessel, control rods, pressurizer and steam generator, and we have turbine in the output side. Also we have electric generators. Finally, the electricity from power plants which is transmitted from power plant to storage unit or town or any city. See how much energy a nuclear power plant produces. A nuclear power plant is a extremely very high in structure, and this nuclear power is extremely rich energy source. We know that very well. Here 1 gram of uranium-235, it delivers as much energy as 3.5 metric tons of coal. Just imagine how huge is this. Just 1 gram of uranium-235, it delivers as much energy as 3.5 metric tons of coal. See here. Okay. Here I have listed some of the nuclear power plants locations. Here we represent the capacity in megawatt. We have different types of power plants which is categorized in terms of energy. Here I have represented power plants in numbers, over 2.4K, over 1.7 to 2.4K, and 1 to 1.7K, under 1K. Okay, what are the pros of nuclear power? We know that rich energy source, 1 gram of uranium-235 delivers as much energy as 3.5 metric tons of coal. Also, reactors run for years without refueling or being shut down and need little maintenance only, and there is no air pollution. Okay, what are the disadvantages? Because it produces reactive and radioactive waste, there is no permanent long-term disposal site. Also, there is a relatively short supply of uranium-235, and nuclear power plants are expensive to build, and minor maintenance problems can be very expensive to fix. Also, we have a lot of safety concerns. Okay, and potential for disaster, we consider the Chernobyl effect. Chernobyl meltdown in the former Soviet Union. Here hundreds died from radiation exposure and thousands contracted cancers from high levels of radiation exposure. See here the Chernobyl effect in Ukraine. And the most serious nuclear accident in the US occurred in 1979 at 3 Mile Island nuclear power plant in Pennsylvania. A small amount of radioactive gas escaped the containment structure here. And While coming into nuclear waste, plutonium, cesium, strontium, and other uranium are the other elements created in a nuclear reactor emits dangerous radiation that can literally knock electrons off the atoms of our cells, disrupting or destroying cell function, or even causing cells to mutate into cancer cells. Here, radioactive elements emit radiation because they are unstable. They would rather be something else. So, we have to concentrate on half-life of the elements. What do you mean by this half-life? Why do we need to calculate the half-life of elements? Here, every radioactive element has a half-life. The longer the half-life, the less intense the radiation. After 10 half-lives, an element is usually harmless. See here, the effect of uranium-235 into 100 million years. After 10 half-lives, an element usually harmless. Okay, and we have to concentrate on nuclear power plant waste. We have some categories of waste. We have high level waste, the most dangerous radioactive waste. It's like a spent fuel comes from nuclear reactors, and liquid and solid waste from plutonium production, and about 70% of the available storage space is now filled with used fuel assemblies at Turkey Point. And also we have waste. It includes clothing, tools, and other materials contaminated with plutonium, neptunium, and other man-made elements heavier than uranium. Also we have waste like low and mixed level waste. It includes radioactive and hazardous waste from hospitals, research institutions, and decommissioned power plants. Okay. In Turkey Point produced annually an average about 2.5 cubic feet of low-level waste. See. Okay, and also we have types of waste of uranium mill tailings. It residues left from the extraction of uranium ore. It is normally 265 million tons. How huge is this? So, finally, we have to do some corrective measures to overcome and to protect this nuclear waste, because it is very harmful for the human life. So we have to concentrate on nuclear waste recycle, and more or less we have to eliminate all the nuclear waste. Thank you.